Today, we're diving straight into a literal mechanical nightmare, the runaway diesel engine. Now, if you've never heard of this phenomenon, consider yourself incredibly lucky. But knowing exactly what it is and, more importantly, how to react in those crucial first few seconds could quite literally save your life, your vehicle, and anyone standing nearby. So, what exactly is a runaway diesel? Put simply, it's a high-stakes engine emergency, where a diesel begins drawing in a secondary, totally uncontrolled fuel source. The RPMs climb rapidly to the point of self-destruction. The engine basically feeds on itself. And the absolute scariest part, your ignition key is completely useless to stop it. Now, this is exactly why turning your key does absolutely nothing. Think about a gas engine. It uses a throttle valve to limit air, and it needs an electrical spark to run. No spark, no boom. But a diesel is a whole different beast. Diesels pull in unrestricted air and rely purely on immense compression to ignite the fuel. So as long as they have oxygen and some kind of combustible vapor entering the cylinders, they're going to keep firing forever, completely ignoring your ignition switch. Because this escalates so fast, you've got to recognize the warning signs instantly. If you're operating machinery and you suddenly lose throttle control while seeing billowing smoke, you are in immediate danger. You might take your foot completely off the pedal, but the engine maintains or even gains speed. You'll hear this distinct spooling roar or a screaming pitch from the turbocharger. And if you see thick white, blue, or gray smoke pouring out of the exhaust, that is a massive red flag. Okay, so what's actually going on under the hood? Let's look at the mechanical root causes of a runaway. If your foot is off the pedal, what is this thing eating to rev so high? Well, usually it's the engine's own lubricating oil. It bypasses busted seals and acts as an unregulated, infinite fuel supply. A turbocharger seal failure is usually the primary culprit here. The turbo spins at thousands of RPMs and uses oil to stay cool. If those seals burst, oil dumps straight into the intake. It could also be worn piston rings, forcing an oil mist through the crankcase breather. Or, if you're in an industrial setting, the engine might just suck in an external vapor cloud, like natural gas, right out of the air. To really grasp the violence of this event, let's talk numbers. Heavy-duty diesels are normally balanced to run at around 2,500 to 4,000 RPM. But a runaway creates this vicious feedback loop. The engine burns oil, the RPM increases, which draws in more air and creates a higher vacuum, which then forces even more oil into the combustion chamber. It will rapidly spike past 6,000 RPM, literally tearing the engine apart from the inside. And here's the kicker. Once cylinder temperatures hit 446 degrees Fahrenheit, that's roughly 230 degrees Celsius, the motor oil just ignites on its own, and the cycle accelerates exponentially. You don't even need a glow plug or a computer pulse anymore. The intense heat of the compression alone makes the ignition of the engine oil entirely self-sustaining. If you panic and just stand there watching this happen, you're looking at catastrophic structural failure, a total engine loss, and deadly flying shrapnel. Within seconds, valve springs fail to close fast enough, and the pistons just slam right into them. Plus, since oil is an incompressible liquid, you get hydraulic lockup, which violently snaps solid steel connecting rods. Ultimately, the extreme heat and pressure can physically shatter the engine block. Which brings us to the absolute worst things you can do during this crisis. Let's cover what not to do. I literally cannot stress this enough. Turning the key off will not stop it. Cutting the battery or hitting the ignition only stops metered fuel from the tank, not the oil vapor that's actually causing the runaway. If you remember one single thing from this entire explainer, let it be that fact. The key is useless. You have to fight your natural instincts here. Do not panic and get ready to act fast. Don't rev the engine trying to clear it out, and absolutely do not just stand there waiting for it to settle down, because it won't. Most importantly, clear the area directly in front of the turbo outlet or the air intake. If this thing explodes, that is exactly where the shrapnel is going. All right, let's get to the core of this explainer, the emergency stopping methods. How do we actually kill this thing? Since you can't shut off the oil, you have to physically choke the engine by starving it of oxygen. Remember, diesels need air to run. First, safely locate the fresh air intake. Second, block it completely with a thick rubber mat, a heavy wood board, or a solid metal plate. Press it firmly against the opening and hold it there until the engine is completely choked out. But please, listen to me carefully here. Never, ever use a loose rag, your shirt, or your bare hands. The vacuum created by a runaway engine at 6,000 RPM is incredibly powerful. The massive suction will effortlessly pull fabric, or your fingers, right into the spinning turbo blades, causing severe, life-altering injuries. Now, if you happen to be driving a manual transmission, you have another option, the stall method. You can force a mechanical stall by using the drivetrain's resistance to brutally stop the crankshaft. First, keep the ignition on so your steering doesn't lock up. Shift into your highest gear, like 5th or 6th. Do not use 1st or 2nd because the engine torque will just overpower your brakes. Hold the brakes as hard as you can and dump the clutch instantly to snap the feedback loop. Another highly effective and safe method is chemical starvation. Grab a CO2 fire extinguisher and spray it directly into the air intake. This instantly replaces the oxygen the engine needs to burn. It's actually the preferred professional method. Just double-check that it's actually CO2 and not a dry chemical powder extinguisher. That abrasive powder will permanently destroy the engine's internal components. If you're around massive marine, mining, or industrial setups, they usually have automatic air shutoff valves built right in. These act as the ultimate failsafe, automatically dropping a physical butterfly flap to choke the engine the millisecond it detects over-revving. It's an engineered solution designed to totally remove human error during a panic. If you operate machinery in hazardous areas with external vapors, you absolutely need to know exactly where this manual override or automatic system is located. Okay, let's take a breath and talk about prevention and what to do after the dust settles. The absolute best defense against a runaway is routine maintenance. Keep your engine oil at the correct level. Overfilling is a surprisingly common way to trigger this disaster. You should also be routinely checking for shaft play and the turbocharger, keeping those crankcase breathers clean, and never, ever ignoring early warning signs like unexplained thick blue or white exhaust smoke. And hey, if you actually manage to successfully stop a runaway, do not even think about restarting it. It requires a full mechanical teardown. The engine might seem totally calm, but starting it could instantly trigger a secondary runaway or shatter a compromised connecting rod. Leave it exactly where it is, throw your hazard lights on, and get it towed straight to a mechanic. So, I want to leave you with this question. If your diesel engine suddenly roared to 6,000 RPM right now, are you prepared to act instantly? Would you instinctively reach for the ignition key out of habit, or would you grab a solid object and head straight for the air intake? Because in these situations, seconds absolutely matter. A runaway diesel is an imminent explosion. Knowing exactly how to suffocate it is the one decisive action that will save the machine and potentially your life. Don't wait until the engine is screaming to figure out your game plan.